Hello, and welcome to this week's Ethical Dilemma in Science, where we're going to take a look at whether electric power plants, specifically nuclear power plants in terms of this example, serve as strategic targets in war, or if they should be considered specifically protected objects. What I'm looking at, again, based on the news, so these are accounts that came out March 4th, 2022. We're sitting down watching the news in the evening on Thursday night, and they were doing live coverage of a Russian attack in the region of Ukraine's largest nuclear power, actually the largest nuclear power plant in Europe. And there were attacks going on in the region of the nuclear power plant, resulting in ultimately a fire in one of the service buildings. But lots of concerns going on with that. Additional news reports that came out later associated with that, taking a look at the attack came to as a near catastrophe, and it had a potential of being 10 times larger, 10 times more dangerous than Chernobyl. So basically, major concerns associated with the attack going on in Ukraine within the last couple of days. What is going on? What is the question? And so to take a step back, try to understand a little bit of the science involved. Basically, what we have in a nuclear power plant is the idea that we've got these fuel elements. So what's represented here in these kind of red and yellow kind of rods that are going to be present there. And so this is uranium. This is kind of a radioactive material that basically gives off energy as it breaks down. And so as it's giving off energy, what's going to happen is it's going to be heating the water around it. And so as that water is heated, it's going to do what water does. When water heats, it expands. It could become a gas. It becomes steam in essence. And then as it's flowing through, depending upon what type of power plant we're looking at, it basically is going to be heating water, producing steam, and that steam is going to cause a turbine to flow, basically a steam generator in this region right here, which will basically kind of spin this around, and as that is spinning around, it is going to turn the turbine and it is going to generate electricity. The whole system kind of recycles, so that hot water and steam kind of condenses down and then circulates back through the system and is heated up again. Now, the issue with nuclear power plants is the fact that with these radioactive rods, they're basically going to give off energy unless these control rods are kind of lowered in between them. And these control rods basically kind of slide down and around and surround these fuel rods. And in doing so, they basically capture or minimize the kind of spread of that nuclear energy, radioactive energy that's being given off by these uranium rods. And in doing so, when the control rods kind of go down, they kind of slow down the production of steam, and the whole system cools down. Now, if we take a look at this, within Europe, and this is looking at the electricity generation within the European Union, estimated by 2020, we can see that by far nuclear energy is the predominant source of energy. And so it's a common mode of energy, kind of followed by gas, wind, and hydroelectric as well. So there are lots of nuclear power plants within that region. When we take a look at this, again, in relationship to the attack that was going on last week to Ukraine's largest nuclear power plant, the whole idea is that, you've got the reactor located in here. This is where the fuel rods are going to be. We've got this system kind of circulating the water, and the water is basically going to be generating steam. Heated water is going to generate the steam, turn the turbine, and then the steam generator, we're basically going to be producing electricity. Now, the whole idea is that you want to keep the radioactive materials, the materials that have been potentially contaminated with radioactivity, in a secure location. And so you've got the fuel rods that are going to be kind of protected by their housing chamber. We're going to have a cooling system which is going to be present. So that as these things start to heat up, you're going to cool it off, because if they get too hot, you run the risk of a nuclear meltdown, where the rods are basically going to kind of continue to release radioactive energy, continue to heat up. And if it starts to melt down, it becomes very difficult, if not impossible, for those control rods to come down and slow down the reaction. And so, we've got the cooling system, we've got the control rods, and then we also have this containment facility kind of around it. Now, kind of anecdotally, I worked at a nuclear power plant when I was in college. There was a saying that, these containment buildings are reinforced concrete, and at least at the time, and I haven't been able to find, direct evidence, so it's at least anecdotal at this point, they were supposed to be able to survive a plane crash into them. But regardless of how strong it is, and there are a lot of standards, the International Atomic Energy Association, agency provides safety guidelines for how we should be designing these nuclear power plants to make them protected, to minimize the risk of release. And it says the containment and shielding structure also provides protection against effects of possible malicious attacks directed against the facility. And so, under normal circumstances, the containment facilities are going to be, pretty strong and able to withstand a lot of what's described here as malicious attacks. But, is it realistic to assume that they can survive, a bombardment occurring in war? Now, when we take a look at nuclear power, there have been, accidents in the past. Hopefully, we've learned from them, improved on the situation. We've got Chernobyl, which occurred, almost 40 years ago now, in the area of Ukraine. Actually, an area that has already been taken over by the Russians in this attack on Ukraine. But we've got an example of that, as well as an example in Japan, where something went wrong, where basically they had a partial meltdown. They had a kind of a loss of control of the nuclear reaction within this. But the containment facility held. The building held. There was a release of radioactivity in both of these cases, but it wasn't a result of kind of failure of the containment system. And so the fear is that, if we're looking at a nuclear power plant in a time of war, potentially that containment building could be damaged, and by damaging that, interfering with the kind of normal control mechanisms, you run the risk of that radioactivity getting out of control, and in doing so, release a lot of energy and contamination in the atmosphere that can have long-lasting effects. So big concerns about that. To indicate that it's not just nuclear power plants, taking a look at a hydroelectric plant, and again, if you remember, a couple slides ago, we looked at kind of the major sources of energy within the European Union. We're seeing that hydropower was in the top 4. Now, the concept of hydropower is basically the same idea. We need to be turning these turbines in some way. We're basically going to spin this turbine here. The spinning of that is going to spin what is going to generate the electricity. Now, with the nuclear power, we heated up water. That water turned to steam, and the steam kind of blew past it and spun the turbine, spun this thing right down here. With a hydroelectric plant, we're going to use something else to spin the turbine. What we're going to do, we're going to build some type of dam-like structure here. We're going to end up with a buildup of water behind it. And then as this water flows down here, it's going to have a path that's going to go through. And so as water is flowing through this, it is going to spin the turbine, the spinning of the turbine is going to spin the generator, and doing so, it's going to generate electricity. If we take a look at this, and I found statistics on the United States going back, about 70 years now. The blue line is looking at the billions of kilowatt hours, so the amount of electricity that's being produced, and this kind of brownish line is percentage of the total. What we can see is that early on in the 1950s, we were seeing about a third of the electricity generated was coming from these hydroelectric plants. Over time, it has decreased in terms of percentage as other power plants have come online, other types of power generation have occurred. But we're seeing that there's still a pretty dramatic amount of electricity being produced by hydroelectric power, especially if we look at the American West. But again, these facilities are susceptible to risk as well, especially in times of war. And so these aren't examples of war, but we're looking at an example in Laos where in 2018 the dam in a hydroelectric plant collapsed and hundreds of people were lost, lives were lost. Destruction kind of downstream to that. Another example here, I think this one is from 2020, an area in Michigan where two hydroelectric plants collapsed. Lots of people fled, lots of property damage, some deaths, but not as many as what we would see in other areas. So there's still a major risk of these power plants, these electric generation plants that are producing electricity, but they have risks associated with them, especially if there become damage to these facilities, either damage to the containment building for a nuclear power plant or damage to the dam in the terms of hydroelectric plant. And so when I started this, the idea is that why aren't these areas being protected? At least I, have watched, old, World War II movies. They're always talking about the Geneva Convention and, you need to treat the prisoners of war right. And you go to these, kind of rules of war. It sounds kind of strange that, you're doing this attack on another group, in this case Russia on Ukraine, but lots and lots of different examples of this as we go out through the history of humanity. There are lots of times where we've coveted what our neighbors have and we've attacked to get that. But it's not all-out war. There are actually rules of engagement, rules that kind of limit and prohibit attacks against specific targets. And so in the process of researching this, I knew about the Geneva Convention, but also learned about the Hague Conventions, which basically the Geneva Convention and the Hague Convention are the foundations for international humanitarian law in relationship to conflicts. And so they have rules for warfare, basically. So prohibition against poison weapons, again, because they can be used and spread against non-combatants, against civilians and other individuals. Protections for civilians and prisoners of war. That's what we saw in the movies about World War II. But there are also prohibitions against attacks on hospitals, as well as defined safety and neutralized zones. This idea that there are going to be certain locations that are off limits to attack. Also, if you read through this, you can see that there are also going to be cultural objects and places of worship that are protected as well, that are ideally not attacked during times of war. Now, I recognize war is awful. War, the fog of war that you hear about. There are things that are going to get destroyed unintentionally. Bombs go off. Off target attacks, kind of in the fury of the battle, are going to go in different directions. But under ideal circumstances, there should be limits to what is going on. And so if you take a look at this and basically rules of engagement against attacks against specific targets, what we can see is kind of in an amendment, basically additional protocols to the Geneva Convention that were put in place in the 1970s. This one, in 1977, is basically this prohibition against attacks or works or installations containing dangerous forces, namely dams, dikes, and nuclear electrical generating stations. They shouldn't be attacks of military objectives, especially if they could result in the release of dangerous forces that could affect the civilian population. And so, again, in war, things happen. But there are rules to ideally prohibit attacks against that nuclear power plant that we saw occurring on Thursday night. And I think it was March 3rd, March 2nd or 3rd, when we were actually watching it on the news. And so then the question then becomes that more than just are there certain locations that should be protected, but should we be doing more to protect those facilities? It's on the rules. It's in the Geneva additional protocols. But we saw the attack occurring. And so one implementation of kind of neutral parties kind of going in and kind of controlling kind of regions attack, and it's being discussed now in Ukraine, is the implementation of no-fly zones where you basically prohibit normally one force which has a lot stronger air force, air superiority, and another region which is decimated that doesn't have the ability to protect against airstrikes. Oftentimes, third parties many times uninvolved directly in the attack, will implement no-fly zones to minimize the effect, the air targeting that would be occurring, the airstrikes. So the question is, do we, consider putting in some type, and this is always easy to, assume you're putting in somebody else, but then should a neutral party like the United Nations peacekeeping forces kind of go in and shield some of these protected objects, referred to as these specifically protected objects within these additional protocols? Should regions like nuclear power plants be in one of those neutralized zones where you go in and the United Nations basically says, okay, this is the region is off limits to combatants of either side because we need to protect that. And so, is this something that should be occurring? Is this, putting in referees in essence, putting in, arbitrators or third-party individuals to go through and shield these very sensitive regions, both sensitive in terms of generation of power, but as well as very vulnerable for increased risk if there was damage to the containment facility, resulting in loss of radioactivity or potentially damage to a dam, resulting in massive flooding and the problems associated with that. So again, some additional references, which I'll be posting in the links below, so you can see the information that I pulled for this talk. And so hopefully this was beneficial, interesting, again, showing you that relationship between science and ethics and tying it in to common, at least common recent events. Recording this on March 6th for things that occurred on March 3rd. So hopefully show you that these ethical dilemmas in science, this application of science and ethics, can apply to our everyday lives, sometimes ideally not with war, but hopefully in other ways as well. So thank you, have a great week, and I'll talk to you later.